Greetings, M squared here, and we are going to talk about graphing some parabolas. So we're going to not make a t-chart every time. So we're just going to look at the pattern, and then we're going to use the pattern. So the pattern that we're looking at, the first two, is the 2 in front when a is 2 or when a is 1/2. So yes, it's a negative 1/2 there, and it can be negative 2, but those patterns are the same. So I'm just going to zoom in a little bit. So we're going to also find our vertex, or axis of symmetry, and we're going to decide whether it opens up or down. So we did that the other day. Well, how do we know if it opens up or down? If a is positive, it opens up. So we know that that one opens up. So I'm going to just put some numbers in, and I'm going to do it kind of in my head. So hopefully that's not too much. So I'm going to put a 0 in. If I put a 0 in for x, I get a 0 out for y. That's 0, 0. If I put a 1 in, I get 1 squared, which is 1, times 2, which is 2. So that means when I'm over 1, I'm up 2. If I put a negative 1 in there and I square a negative 1, negative 1 times negative 1 is positive 1, and then I'd have to multiply that by that 2, so I also get a 2. I'm going to put a 2 in. That's 2 times 2 is 4, and then I'd have to multiply it, so that would be 4 times 2, which would be 8. So I'm just going to kind of, and then this side would be the same. I'm going to kind of show you what this graph looks like, because this is going to be our model for our other ones. So I want you to notice, when we did our parent graph the other day, we went over 1, up 1. Now I'm over 1, up 2. Notice the 2. And the other day when we went over 2, we were up, from this one we went up 1 over 3. Notice to this one I'm going to go up 1, and then I went up 6. So did you notice that it used to be up 1 over 2? I've doubled it, and then I doubled the 3, which was 6. So that's kind of helpful in your pattern. The vertex, because I didn't shift yet, we're going to talk about shift in a minute. The vertex is 0, 0, but I want you to see that pattern. Over 1, up 2, over 1 more, up 6 more. Okay? Axis of symmetry is x equals 0. So this is our pattern for 2. Now we're going to look at our pattern for 1/2. And then we're going to graph some guys. So again, 0, 0, because I don't have any plus or minus. This one opens down because it's negative. So when I put a 2 in, now the reason I put a 2 in is because that's a 1/2, and I don't want to get stuck with like fractions. Well, I'll just do the 1 real quick. If I put a 1 in there and I square it, I get 1 times negative 1/2. So if I'm over 1, I'm down 1/2, and it works the same on the other side too. If I put a 2 in, I get 4, and then half of 4 is 2. So if I'm over 4, I'm down 2. I'm sorry, if I'm over 2, then I'm half of 4 right there. Okay, and if I go over, I'll go over a little bit more, because when they're vertically compressed like that, it's hard to see what's happening. So I'm going to go over from 2 to 4. I'm going to go to 4. So 4 times 4 is 16, and half of 16 is 8. So I would have been down negative 8 if I went over 4. So I would be right here, like that. So you can see, I could show you that if it was just the parent function, it would have looked like this. So you can see that it's, I'm going to just kind of dash that. You can see that it's wider, right? It's vertically compressed. Whereas this one, if we did it over here on this one, it would have looked like this. 1, 2, 3, 1, 2, 3. It's you can see that this one would have been a little bit skinnier. Okay, so with those patterns, notice I went over 2, down 2, over 1, over 2, down 2. That pattern is going to be super important, because here's what's going to happen. We're going to go and we're going to remember what happens when we shift. When we shift, that number inside, remember that's the x minus h squared plus k. The h tells us whether we're moving left or right. If it's negative, we're moving right. It's weird that way. When it's positive, we're moving left. So I know that I've moved left, that the vertex is left 4 and down 5. Oh, I forgot to do my vertex over here, didn't I? Let me go back and do that real quick. 0, 0, x equals 0. Okay, so I'm going to go ahead and graph that, because that's going to be our new starting point. 1, 2, 3, 4, 1, 2, 3, 4, 5. And I'm going to notice, is it opening up or down? It's opening down. Okay, that's really important to notice. The axis of symmetry is going to go right through there, so that's just going to be x equals -4. Notice it's always whatever the x is of the vertex, because it goes through the vertex and it's an x equals line. That's why we look at x. Now we're going to notice our pattern up here. Remember our pattern where we go over 1, up 2? And since it's going down, instead of putting numbers in, if we recognize our pattern, we're just going to go, oh, I go over 1, down 2, over 1, down 2. And then next, you'll see that it's kind of off the grid, because then I'd have to go over 1 more and up 6, and that's off. So I'm just going to connect the dots. If it's off my grid, I can just do that. So I just graphed that, and I didn't really plug in very many points. That's the handy-dandy part of knowing about the shifts and the patterns. So here, let's go for our vertex. Vertex, right 2, up 3. So right 2, up 3 is my new vertex. It opens up because it's a positive 1/2. My axis of symmetry is whatever the x is on my vertex. And I'm going to use my 1/2 pattern. Okay, my 1/2 pattern is over 2, up 2, or down 2, depending on whether it's up or down. So over 2, up 2, over 2, up 2. Now you can always plug something in and see if it actually works. You can plug in 0. This is our x equals 0. If I put a 0 in there, I get 0 minus 2. Then I square it, which is 4. Then I take half of it, which is 2. Then I add 3, which is 5. Am I at 5? 1, 2, 3, 4, 5. Yes, so I know I'm on the right track. And then this part was over 2 more. 1, 2, 3, 4, 5, what's that, 6? 1, 2, 3, 4, 5, 6, yeah. So I don't think I have 6 there, right? But I could kind of pretend there. Over 2, 1, 2, 3, 4, 5, 6, just a little bit. So I can kind of figure it out. Okay, there's my graph. Now, I'm going to help hopefully remind you of the absolute value. Now, the absolute value, this number out front, was constant. It was our slope. It didn't change like the parabola does. The parabola doesn't have a constant rate of change. Did you see it went over 1, up 1, then it was over 1, up 3 on our parent function? But this one was a constant rate of change. So my vertex, still 5, 4. So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4. And then my constant rate of change is 2. So that means one side, it was a up 2 over 1, and the other side was you went over the other, but it was still up. So one side had a slope of 2 and one side had a slope of negative 2. My axis of symmetry was still 5 and it was opening up. And I put a V, not a U, because it's an absolute value. Okay, so my slope's going to be 1/2 on this one. What's my vertex? Well, it's going to be negative 4, and then there was nothing here, so that's a 0. So my axis of symmetry is x equals negative 4, and I know it's opening up. And I know my slope is 1/2, so I go over 1, 2, 3, 4, and then I go, and my slope is up 1 over 2. And this is just such a neat way to graph if you remember these things, because you aren't making a t-chart. You aren't saying, oh, what happens when x is 5, what happens when x is 3. You just remember the pattern. So having those patterns is going to be super important. Now we're going to talk about a pattern. What if it was 3? And you can do this with any old number, but I'm just going to do 3 1/3. So basic one right here, 0, 0, 0 squared is 0 times 3 is 0. If I put a 1 in, I'm up 3. Because 1 times 1 is 1, then times 3. And then if I put a 2 in there, I get 2 times 2 squared, which is 4, and 4 times 3 is 12, so I'd actually be off my grid a little bit. I'll just put it up there, just so you can see how it's going to go up very quickly. Going to get skinnier. Okay, so my vertex was 0, 0 on this one. My axis of symmetry is x equals 0, and it opened up. This one, 1/3, if we put a 0 in there, we get a 0. What if we put a 3 in there? If we put a 3 in there, it's 3 squared, which is 9, and then times 1/3, which is 3. So if I go over 3, I'm up 3. Remember the pattern when it was 1/2? It was over 2, up 2. And what if I put a 6 in there? I get 36 divided by 2, which is really big. So I'm not going to do that, but 36 divided by 2 is 18. That's off my grid. But you can see it's a little smaller. And so usually they wouldn't have you graph them. But anyway, it opens up because A was positive. Axis of symmetry is 0 because the vertex was at 0, 0. So we're not going to be able to graph very many points. We could put something else in and get a decimal approximation. Well, I'll just show you how to do that. For example, if I wanted to see what was happening at 5, that would be 25 divided by 3. which is 8.3. So if I go over 1, 2, 3, 4, 5, then I'd go up 8.3, which is like right there, and then you can kind of see it kind of going up. So what was that? 1, 2, 3, 4, 5. And the axis of symmetry is nice because it tells us what's happening on the other side if we know what happens on this side. Okay, so now we're going to take that pattern, that up 1 over 3 or the up 3 over 3, and we're going to apply it to shifts. So the vertex changed because I shifted right 1 and I shifted up 4. So 1, 4. It's upside down because it's negative, and my axis of symmetry is x equals 1. So since it's a 3, I know I'm going over 1, down 3, and then remember the next one was down, what was that, 3, 6, 9. So I could probably do that here. So over 1 more, and then down, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you can see my axis of symmetry is going to go like that. And again, you could always check a point. So for example, that point right there is negative 1. If we put a negative 1 in there, we get negative 1 minus 1, which is negative 2. When we square a negative 2, we get a 4. When we times 4 by negative 3, we get negative 12. And when we say negative 12 plus 4, we get negative 8. And so that is where I am right there in the graph. You could always double check. You don't have to use the pattern. You can always plug in things. Okay, I meant this to be a third because we're doing the 1/3. So let's go to that. So what's my vertex? It's 0 because there's nothing inside with the squared, and then down 7. So it's 0, negative 7. So that is right here. And then it's a 1/3 pattern. So that's over 3, 1, 2, 3, up 3, and 1, 2, 3, 1, 2, 3. And we just, because it's so wide, we're just going to leave it like that. And now we're going to take this to absolute value. What's my vertex? Oops, I didn't do my axis of symmetry. X equals 0, and it was opening up. So my vertex is positive 5, 0. So I'm going to go 1, 2, 3, 4, 5. And then again, remember absolute value? That told me the slope, so I was up 3 over 1 on both sides, and 1, 2, 3, 1, and that's a constant rate of change, so I'm just going to graph it like that. Axis of symmetry is x equals 5, and it's opening up. This one's opening down because a is negative. My axis of symmetry is x equals negative 2 because my vertex is negative 2, 6. It's absolute value, so I go over negative 2, up 6. And I use my pattern, which is my slope pattern, which is down 1 over 3. Down 1 over 3. And that stays the same. And so I connect the dots. Great. Okay, hopefully you can recognize those patterns and use them to help you graph. M squared, sign in.